Okay, working on number 2. We're just going to start over so the video makes sense. So, as always, I want you to practice reading slow and careful, stopping frequently to either write something down or remember a key flashcard idea. So somebody raise your hand, and actually I'll just call it something. Maddox, where would you first stop reading to write something down?
Probably primacy.
Just a recommendation, I would have stopped sooner. It says the number of gallons. So right there is the problem talking about an amount or a rate?
An amount.
Yep, so I would write that down. So I put on my paper, Christmas bonus for Maddox, he gets 5 points. So we write down amount is P of T. That's being measured in gallons. So we go to Maddie. Where would you stop next to either write or remember something?
Like for the rate, would you do primacy?
Yep. 5 points for Maddie. So P prime of T, that's in gallons per day. So Jesse, where would be the next place you would stop to write or remember something? So what would you do after reading that? Yeah, no, you're right. There's a way to. So something that they always do on the AP test, this can help you understand their strategy. They are testing to see if students can understand calculus in terms of words, formulas, like equations, tables, and graphs. So they are always trying to see if they can find a new way to express an idea in one of these 4 methods and see if you can translate. So they're giving you information in words, but I want to translate it to a formula. Go ahead, Jesse.
Would it be P prime of 0 equals to E? Or no, would it be P 0 equals to?
There we go, 5 points. Question. Cool. The last one is a little bit different, so I'll just show you what I would have written. I would write safe if the level of pollution in the lake is less than or equal to 40. So I get that written down. Now I read the problem. It says, at what time will the number of gallons of pollutant be at its minimum? So I remember the min-max theorem. So now I'm going to write on my paper the min-max theorem so I know I will understand what I need to do. So I write, let's see, the min value of P of T is either the value of P at the very first time I can check, P of 0. The very last time there is no last time, it goes on forever. So that's a little hard to write, but I kind of write something like this. Or value of P of T as time goes on forever. Or the value of P of T where P of T has a relative min. Questions? Please, Sherry.
Do you have to write that part where ST goes to infinity? Because last time we only wrote the P of 0 part.
So that was my error last time. And to be honest, they're not going to give you any points for this. I just have found for many years that if I don't keep having you write it, you don't usually complete the problem successfully.
If you wrote that wrong, would they take points off?
Yeah, because the rest of your work's going to be wrong. Because you're using this to guide the rest of what you do. So if there's an error, like if the wording's a little bit off, it's no big deal. But if the idea is wrong, then you'll make mistakes further on, so you lose points. Is that true?
Well, like, for some reason you wrote it wrong, but in your head you had it correct.
Oh, I
And you
gotcha.
weren't like following it, you just had it written down just in case you like forgot what you were thinking, but you had it written down different.
We just kind of depend on what the rest of the work showed. 5 points for good question, 5 for charity. Ethan, once you see that on the board, it should prompt you to write something else. What would you write?
What you do?
Sorry, this one.
Just read that. You're going to, you're gonna want to plug the formula into your calculator to see like where the relative mean is. But you're also
Perfect,
gonna
perfect,
see-
perfect. So I just need a statement to remind everyone of like why we're doing what we do. Like what's the statement? We've written this before, do you remember? So I'll help you. So P of T, we must determine where does P of T have a relative min.
Yeah.
P of T has a relative min.
Has a relative min when P prime changes from negative to positive.
5 points for Ethan. Now we use our calculator to find that time. Has anyone found that time? Alex, what you got?
Yeah, 30.173
5 points.
or 174.
And make sure we store that value like that. Questions? Please, Charity.
Do we find that point like with a graph?
Yeah, so what I would do is I would put in my calculator the formula for P prime. So here's my formula for P prime in the calculator. I need to graph that. I don't know how far to go. So it might take a few guesses and checks, but I'll just cheat and tell you if you go to 50, it works pretty good. And then once we have the graph, we can do exactly what Maddox did. These are the values of P prime. So these values of P prime are changing from negative to positive right here. So I use my calculator to find that time. 5 more for Jerry. Question? Anybody else? Update the roll. Jackson's here. I think that's it. No, Ethan's here. My bad. No. Cool. Questions? So Anna, what would you suggest we do now?
Then we have to find Oh, then we have to plug B and 0 into PFT.
Right thinking, I would probably change the wording just a little, but I think you're fine. We need to go find the value of, like we know the value, we know the level of pollution in the lake at time 0, which could be the moment when the pollution is actually lowest. We need to go find the level of pollution at time B, so we can use the fundamental theorem to say the pollution level at time B will equal, the lake has 50 gallons at day 0, so these two items have to coincide. This number has to coincide with this number. On day 0, there are 50 gallons of pollutant in the lake. If we integrate P prime, we'll discover how much the level of pollution in the lake changes between day 0 and day 30, like that. 5 points red. Questions? We have that number on their calculator. Here's a good idea too. I think it's smart to just kind of verify that the units you're using are making sense. So we'll go to Ethan Valletta. What would be the units for P prime, Ethan?
I don't know.
So read the problem slow and carefully, you'll find it.
Gallons per day.
There we go. So P prime is gallons per day. And in the integral, we're multiplying some number of gallons per day by dt. dt stands for duration of time. So what are the units for time in this problem, Ethan? Days. So when I multiply gallons per day and days, what final units do I get, Ethan?
Gallons.
I get gallons, which is what I'm hoping to get because I've got 50 gallons sitting right here. And I need to combine these 50 gallons with some number of gallons there. So 5 for Ethan. Who has, yeah, Jason.
Oh, I have the answer.
Yeah, what do you got?
It's 35.104 gallons.
So I want to emphasize something. So I need the value of the integral. It's negative 14.
0.896.
Thank you. So Jason, what are the units of the 50?
Gallons.
What is that representing?
How much is already in?
Perfect, on day 0.
Yeah.
And Jason, what are the units of the, we'll call that 15?
Days. Gallons per day.
So that would be a problem because I don't know how to add 50 gallons
Oh.
to 15 gallons
So it's
per
just
day.
gallons.
It's just gallons. This is gallons, this is gallons, and you need to, mentally check that that's working, so you're not making an error. 5 points for Jason. Jackson, what is that number, negative 15, representing?
The amount of gallons that changed from 0 to B.
Perfect, perfect. It's all about the change. It's not how much pollution we have, it's how much did the pollution level change. 5 points. And so then Jason, read that final answer again.
35.104.
Thank you. 5 points for Jackson. Questions? Please, Maddie.
I just plugged in the function and then I just added 50, so I didn't do the plus negative 14. Is that, did you
Oh, I
just do that
gotcha.
to help show us with
So,
do that?
do you have written on your paper this line?
Yes.
And then did you just kind of write something like this maybe?
Was it gallons? But yeah.
Like that?
Yeah.
That's totally fine.
Okay.
I wrote this line because I think it is important to keep emphasizing this is how much pollution is in the lake on day 0. Like it's the amount of pollution on that day. This is not the amount of pollution on any day because that number came from computing something that happened over 30 days. So this is the change in the amount of pollution over those 30-day period. So I wrote it out to emphasize, but you don't have to. So, is that what you meant?
Yeah.
5 more. Cool. We do need to do one more thing that's we haven't done before. We have to account for this right here. The grader is going to check to see if the student pays attention to that. So you have to write something to address that particular item. Here's a good thing to write. You can write that for time greater than 30.174, P prime of t is positive. So P of t is increasing for all time greater than 30.174. Any questions about that so far? This will earn you, this is part of what's required to get the points. So. Okay? Therefore, at time equal 30.174, P of t has its lowest value of 35.104 gallons. Question? Cool. Next one. Go to number 3. Okay, for number 3, we get a bit of a head start because the problem is about particle motion. So you can basically memorize the amount and rate that we need. So if we're talking about particle motion, the amount is position, x of t. They don't give us units, but we could write meters if it helps us think. The rate is velocity, v of t, perhaps in meters per second. Questions? Cool. They do give us one other piece of information. They say that at time 0, the particle is at this position. So we'll try to give somebody else another 5-point Christmas bonus. So Connor, that green item that I circled, that they're giving you that in words. They're trying to see if you can translate that to a formula. What would you write?
X of 0 equals 1.
5 points. Nicely done. X of 0 is equal to 1. Perfect. Questions? Okay, they say for this time period, what is the greatest distance between the particle and the origin? So this is what they're talking about. Particle is moving along a horizontal path. They designate the center spot as the origin of the path. It's not where the particle begins. The particle begins at location 1. But they want to know, as this particle moves back and forth, when is the particle furthest from the origin? So the particle might be furthest over here somewhere, but it might be further over here somewhere. So I'm actually looking for the max and min of the position. Questions? Cool. So Jacob, how do I write the max-min theorem as it applies to position for this situation? I'll help you get started here. We write the max slash min value of x of t. I don't know if that's enough to get you going. Do you know what comes after that?
I did not notice the 0 to 5 before. Okay. No, I'm not exactly sure.
You're okay, I'll keep helping. But this is exactly why I really want you all writing it. It just doesn't seem to stick. But the more you write it, the more it will stick. So I would write it down. The maximum value of x of t is at, or will be, either the position at the beginning of the time period. What comes after that, Jacob?
Or x of 5.
There we go.
Or the r min or r max.
There we go. Or the value of x of t, where x of t has a relative min or a relative max. 5 points for Jacob. Gideon, when you read that, my hope is that that would prompt you to write another statement that will also help us. What's the other statement that's going to help?
X of t will have a relative max or relative min when it changes sign.
There we go. One bad word in there, but the rest were good. X of t has a relative min slash relative max when, what comes after when, Gideon?
X of t.
So look over here to find your mistake. X of t, here's x of t, has a relative min when x of t changes from going down to going back up. But we identify the relative min on x of t not by looking at x of t, because we have no formula for x of t. So what do I write over here, Gideon?
When v of t.
There we go. And a short way to write it is when v of t changes sign. 5 points for Gideon. Questions? So Lexi, what do we do now?
Do you graph it?
Just don't swear it, and it makes me feel sad.
Do you graph v of t?
There we go. So graph v of t. Let's see. 2003 2D. Perfect. Gotta get the window right though. That's the wrong window.
0 to 5.
0 to 5. Once I have v of t graphed, Lexi, what do I do?
Now do you find the places where there's a min or max, relative min or max?
Yeah, I gotta be careful how I say that though.
Sorry, the zeros.
Yeah, I want to find these times here. These are the times when v of t is changing sign. So those are the times when the position could be greatest or least. So, did you find any of those, Lexi?
I haven't yet.
Keep going. 5 points for Lexi. Anybody have them? And
The
then,
first one is 2.5.
Jason's got it. What is it?
The first one's 2.507.
5 more points for Jason and Anna. Make sure that gets stored somewhere for later use.
The second one is 3.545.
3.545.
Yeah.
Last one, Jason, since you're hot on the trail.
Is .342.
I see that. Five more for Jason. Question? So Haley, what would we do now? Say again. So go back and read the purple. The whole reason we wrote down the purple was so we wouldn't get lost as to what we're trying to do. Does the purple give you a clue as to what we could do next? You're on the right path. What we're going to do is we now know the AP test calls these candidates. Candidates are x of 0, x of 5, x of this time, and this time. So we want to go find those 5 different positions of the particle. So keep helping me for a minute. So I look at my chart here. I'm looking to find positions. I have all there is to know about velocity because I have the formula for velocity. So I know I'm going from rate column back over here to amount column. So I'm going to use the fundamental theorem. So we start doing it. Haley will help me here. Clear that off. So we already know that x of 0 is 1. We can just write that down. Haley, what version of the fundamental theorem would I, how would I write the fundamental theorem if I'm trying to determine x of 5? So I know I have to use the fundamental theorem, which is this. I know I'm trying to find x of 5, so somehow x of 5 fits in this. How do I write the fundamental theorem so it includes x of 5? Let me help a little bit. What's the rate in this problem, Haley? So the rate is the velocity. So we're going to integrate the rate. So I can write that. And what's representing the amount in this particular problem? No, look at our table. What represents the amount? X of t. So I can write x of something minus x of something. That's how the fundamental theorem applies to this situation. Make sense? What 2 times do you think we should focus on, Haley? 0 and 5. So 0, 5, therefore this must be a 5, this must be a 0, 5 points for Haley. Question? Cool. Sabrina, do you have your calculator set up to find this integral? Oh, you're doing it differently? It's okay. Who has that integral? Let's go, Jackson.
It's 0.31.
Positive or negative?
Positive.
So 0.310. Is that just the value of the integral?
No.
Oh,
That's
well,
plus
after you
one.
add 1. Sorry.
Yeah, you're okay. What's the value of the integral?
Negative 0.69.
So negative 0.690.
Yeah.
So, Carrie Ann, what is this number representing?
That's the change in velocity rate between 0 and 5, like the change in amount going up.
Close. So in this problem, what is representing amount in this problem? Look at our chart.
Meters, right? That's what we decided.
Yeah, x of t, position.
Right.
So the amount is being represented by x of t, which is position, the location of the particle. What is What is the rate in this particular problem?
Velocity.
That's the velocity. So whenever we integrate velocity, we are finding how much the amount changed. We're not finding how much the velocity changed.
Okay, so it's the change of the amount.
Change of the amount.
Thank you.
A way to think of that is this. Carry on, if you had a particle that just happened to have a velocity of -3 meters per second, I'm just making up the numbers, and you knew the particle had that velocity for 5 seconds, what would those numbers tell you about the particle?
That's just how fast it's going for 5 seconds.
Say again.
How fast it's going for 5 seconds.
True. It tells you something else, though. It tells you that after those 5 seconds of time have elapsed, the particle will be 15 meters left of wherever it was. So whenever I take a velocity and I multiply by an amount of time, I am computing how different the particle's position is, the change in the position. So over here, that's what I did. I've got the velocity and an amount of time. They're multiplying. This represents how much different the particle's position is. And so we know x of 5 is what we're looking for, 5 points for Carrie-Ann. X of 0 is 1, so then we add over the 1. So we end up with 1 plus -0.690. So golden, we get this number here, which is was it 351, Jackson? No,
3.10.
301?
3.310.
310, thank you. Can't do math in my head. What is the point 310 representing, Golden?
That's the position.
That is the position at time 5. It's right where the particle is sitting at time 5. 5 points for Golden. Question? Could not be more exciting.
Very exciting.
Yeah, I can tell. Sense the excitement in the room. What's left now is to go find the other positions. Once you find the other positions, you'll have a list of 5 different positions. From that list, you can determine when the particle is farthest from the origin. Have a wonderful Christmas break. Good job, guys.